In section 2 of chapter 9, we're going to start working with the measurement of angles. So we've done a little bit of that in talking about right angle trigonometry, and now we're going to be moving on into talking about angles other than right angles. And in this section, we want to make sure that we understand how to use radian measure. You should already be familiar with measuring angles in degrees, and we're going to use a different type of measure called radians. We want to be able to evaluate and use general angles, and we're going to want to be able to calculate arc length and sector area, which you probably have already done in geometry. So the key vocabulary we're going to want to talk about is the initial side of an angle. That's basically the side from where you begin, and the terminal side where the angle ends. Standard position would be the initial side on the positive portion of the x-axis, so moving from 0 toward infinity on the x-axis would be standard position. Coterminal angles are angles that have the same terminal side. So they have the same initial side and the same terminal side, and they're called coterminal, but they're different angles. So we'll talk about how that happens. We're going to define radians, which would be good if we're going to use radian measures. We need to know what they are. And we're going to talk about the sector, right? So the sector is the area that is created by an angle. So let's say I have an angle like this, and when I come around and I attach the points here, this line here, the curving line that closes off what would be a triangle if it was a straight line, but it's a curved line, that's called an arc. And a sector is this pi wedge that's been defined by the angle. And we're also going to talk about central angles. So this would be a central angle because it's inside my sector. Okay, so how might we use this? If we have a softball field, it forms a sector. That's what I talked about. This pi wedge would be a sector. And the fence is an arc. So if we wanted to look at using these dimensions, if we want to find the length of the fence, it's complicated to calculate its length because it's curved, so the distance formula won't work. So I will have a new formula for calculating the length of an arc. Okay, so we could find that length of the arc and the area of the field. That would be sector area. Okay, so let's just talk about some angles. So when we talk about angles in standard position, this is what I was talking about. My initial side, you see, starts at the origin and moves toward infinity on the x-axis. That's the initial side in standard position. And then wherever my angle ends, this would be the terminal side. So the initial side is where it starts, and the terminal side is where it ends. So if I want to just really quickly draw some of these angles in standard position, this would be -10. So I would have, actually let's use the line tool. So there's my initial side, and then my terminal side would be in this direction. Positive angles go counterclockwise, negative angles go clockwise. Again, if we were to go ahead and take a look at 450 degrees, now that's complicated because my whole circle is only 360 degrees. So if this is my initial side, if I go all the way around my circle back to where I began, that's 360 degrees. But I need to go another 90 degrees. And that's here. So when we have angle measurements that are more than 360, that means we're going more than all the way around the circle. Okay, but this would be the angle in standard position. So if we go back also to our vocabulary and talk about this, you'll notice that this has the same initial side and the same terminal side as 90 degrees. So 90 degrees and 450 degrees are coterminal angles. Okay, we'll talk about that more later. Now this is a little complicated because now we've got this weird measure, 5 pi over 18. Well, this is a measurement in radians. Okay, so we're going to talk I'm going to talk really quickly about radians and do this problem, and we'll talk more about radians in a minute. So if you think about the circle, in radians, all the way around the circle is 2 pi. So radian measures are typically in terms of pi. That's something that's different, right? So we have our measurement in terms of pi. And you can see that once around the circle in degrees is 360 degrees. Once around the circle in radians is 2 pi. So when I'm looking at 5/18 pi, how many is that? Well, if all the way around the circle is 2 pi, halfway around the circle is 1 pi, halfway would be pi over 2, and you see this one is a little, what is this? It's a little less than a third, right? So pi over 3 would be somewhere around here, and if we made it a little less than that, then we could say this is 5 pi over 18, okay, about. Okay, so we'll talk more though about radian measures in a little bit. Remember, this is going to be a little over 1 pi. This is not quite all the way around the circle. So let's go ahead and do that. If we go 250 degrees, again, my initial side is here, right here at the x-axis. And when I start traveling around the circle, I know that's 90, that's 180. If I went all the way to here, it would be 270. So it's going to be less than that. So it's going to be right around here. Okay, so the distance, and we're going to talk about some of this, this is 255 degrees. What's important as I was working with this is I went, this would be 180, so then I would have gone another 75 degrees, so this would be 180 degrees to here, plus my 75 degrees, that gets me to my 250 degrees. In later sections, we're going to be talking a lot about this angle, the distance from the x-axis to my terminal side. But for now, I just want you to think about how we got there. All right, when I work with this angle, 7 negative, so okay, it's a negative angle. That means I'm going to go clockwise instead of, normally we go counterclockwise. I start on my initial side. I know that this would be pi, so if I travel from 2 pi around this way, that's negative pi, and then I have to go 1 more sixth, okay, because it's 1 1/6 pi. And there we go. So again, thinking about this angle, right, this would be negative 6/6 pi, because that's negative 1 pi coming this way. And then over here it would be negative pi over 6. I went 1 more sixth. Okay, so just thinking about breaking that into parts. Go ahead and do a little practice. Do problems 3 through 5. That's a matching problem, so you can get the sense of it. And then do problems 6, 9, and 10. And then come on back and we'll talk some more. Okay, so we've talked about radians. 1 radian is the measurement of an angle in standard position whose terminal side intercepts an arc that has the same length as the radius. So the arc length, when the arc length matches the radius, then you have 1 radian. Okay, and then when you look at the circumference, the formula for the circumference of a circle, you can see how we end up with 2 pi radians. That's not something we actually have to do, but that's where it comes from. Circumference of the circle is 2 pi r, right? If I take 2 pi r and I want to find out how many radians there are, the r's cancel and I get 2 pi. So around the whole circle is 2 pi. So that means this is pi over 2. This would be 3/2, so 1.5 pi. Okay, now if we want to then go from radians to degrees or degrees to radians, we create a ratio with degrees to radians. This is once around the circle, and I could do it either way. And when we simplify it, we get this right here. 180 degrees equals pi radians. So my ratio is 180 over pi, or pi over 180. And your guide for which of these to use to convert is by what's in the denominator. So if I multiply this times an angle that has pi in it, meaning an angle that's measured in radians, the pi's will cancel out and I'll get degrees. So if I have degrees over radians times radians, the measurement radians, let me go ahead and write this down. When I have degrees, actually, let's move this thing out of the way and let's put this up here where it matches what it's next to. When I have degrees over radians times radians, my radians will cancel and I'll get degrees. So this formula here, because degrees are in the numerator, will convert from radians into degrees. And this one, pardon me, this one, if I multiply it times degrees, because I have radians over degrees times degrees, will give me my answer in radians. So again, the key here is these formulas convert from degrees to radians. You know what you're doing by what's in the denominator and tracking units of measure, because when they cancel, that will leave you with the right thing that you're looking for. And that's true of anything. If I want to convert from, meters per second to miles per hour, I can be guided throughout the process by following the units of measure and how they cancel in fractions. This also relates to chemistry in stoichiometry, if you've been doing that, where you start using different formulas to convert from one thing to another. You're guided in terms of how to arrange those ratios by how the units of measure cancel. So you go from the unit of measure you have to the unit of measure that you want. Okay, so this is kind of this idea here that I'm working with is rather universal. Okay, when we start talking about radian measures and special angles, this is something called the unit circle. Okay, it's called the unit circle because it has a radius of 1 unit. Okay, that's why it's called the unit circle. And this is going to allow us, this is the beginnings of the unit circle. Right now, this is just a chart that relates radian measure to degree measure. So you see in blue, I've got radians, and in red, I've got degrees. And this measures all of what we call the special angles or the common angles. So they're multiples of 30 and multiples of 45. Okay, that means that in radians, those are multiples of pi over 6 and multiples of pi over 4. Okay, so later when we go through working with the unit circle, we're going to add some more information onto this. But for right now, this just shows you how radian measure and degree measure relate to each other, which we've already talked about earlier in this lecture. So you might want to locate this in your book as you work so you can help, since I think for most of you, you're used to thinking in degrees, and for some parts of our chapter, we're going to want to think about angles in terms of radians. So you might want to locate this chart in your book, or just copy it out of here. You could always make a PDF of this. Okay, we've talked about these formulas. I showed you them earlier. If I want to convert, if I want to go from degrees into radians, I multiply by the item that has degrees in the denominator. Okay, and then what I'd want to do is I'd want to simplify this. So I get 315 pi over 180. And I can see that 5 goes into this. I can cancel 5 out of that. Let's see if that's enough. So that'd be 63 pi over 36. And then 9 also will go into that. So that's going to be 7 pi over 4. So 7/4 pi. Okay, if I want to convert from radians to degrees, I multiply by the item that's got pi in the denominator, because the pi's will cancel. Negative number times a positive number is going to give me a negative number. And 4 goes into 180 45 times, right? So negative 45 degrees. Okay, so these are pretty simple formulas. You want to make sure you use the right one. If you track units of measure, you'll know you did it wrong if you end up with degrees squared or pi squared, because it means you used the wrong conversion ratio. Okay, so it's pretty simple. Go ahead and give it some practice. Do problems 23 and 27. Come on back and we'll finish this up. Okay, so now if we want to work with arc length and sector area, we have a couple of simple formulas to use, but the key thing you need to remember is that my angle has to be measured in radians. That might be why we learned how to convert from degrees to radians. Okay, so if I want to do these problems, they're in degrees now, first thing I have to do is convert to radians. So I'll have 45 degrees times pi over 180. 45 goes into 180 4 times, so this will become pi over 4. Now that I've converted, I can use these. I know that my arc length, S, will be my radius, 15 centimeters, times pi over 4, so that would be 15 pi over 4. And if I want to work with my area, that will be 1/2 times my radius squared, 15 squared, times my angle, pi over 4. So 15 squared is 225. Pi over 2 times 4 is 8. This is my area. Okay, if I do the same thing over here, the first thing I'm going to do again is convert from degrees to radians. I know 90 will go into this 3 times, and it will go into this twice. So I get 3 pi over 2. All right, if I want to calculate my arc length, it's going to be my radius, 25, times 3 pi over 2, which would be 75 pi over 2. Okay, you can leave it in terms of pi, that's not a problem. And when I do my area, I'm going to have 1/2 times 25 squared times 3 pi over 2. I'm going to want to pull up, I don't happen to have in my head what 25 squared is, so let's go ahead and find that out. 625. So I'll have 625 pi over 2 times 2, which is 4. Okay, so that's doing arc length and sector area. It's pretty simple. Go ahead and practice that, and then we'll go back to our baseball field. So do problems 32 and 35, and we'll find out the length of the wall in the outfield and the area of the baseball field. Okay, so they've given me this angle. It's 90 degrees. I know from discussing this earlier, right? We know that this is 0 and 2 pi. This is pi, and this must be pi over 2. So rather than using the conversion, it's a common angle. I'm just going to look here. It's pi over 2. I know that. I know that the length of my fence is going to be the arc length, and it's going to be my radius, which is 180 feet, times pi over 2. So the length of this guy is going to be 90 pi. And if I wanted to get that more, normally we wouldn't talk about feet in terms of pi. So if I take 90 times pi, I get 282.74 feet. So it's about 283 feet. So it's approximately 283 feet. Now if I want to look at the area of this field, then the area would be equal to 1/2 times my radius squared times pi over 2. So we'll go back to our calculator. We'll go back to the calculator, and we'll square 180. And then we're going to divide it by 4, because my denominator would be 2 times 2, which is 4. Divide it by 4. And then if I multiply it times pi, 25,447 square feet approximately. So 25,447 square feet. So this is an abbreviation for square feet, or you could also do this, feet squared. Alrighty, so that's how you use arc length and sector area to calculate area and distance in a more authentic application. That's the end of 9.2.